Now we're looking at a special limit, and that is the limit as x approaches infinity. As x gets larger and larger and larger of 1 over x, then the limit is 0. Never actually hits 0, but it approaches 0. And it's also true for 1 over x squared, x cubed, any time that the index of the denominator is larger than the numerator. So why is that? We can have a look graphically why that might be so. We'll have to think about our scale here, but let's just do something like that. So let's say that's 10, that's x equals 100, and that's x equals 1,000. So if I'm subbing in to 1 over x, well 1 over 10 is 1/10. So let's call that 1 there. So 1/10 is about there. So I'm going to plot a point there. That would be the coordinate. And then if I look at 100, 1 and 100 is much smaller. So that could go about there. Make that dot big enough. And then if we take 1 and 1,000, well, you can see it's getting smaller and smaller and smaller as we go along. So it's coming down, 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 miss those points, down, 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 and approaching 0. So you've just got to think about it. As x is getting bigger, this fraction here is getting smaller and smaller and smaller. So 1 on a million, is virtually 0. So that means that any time you're trying to work out a limit, and it's of this form, so let's say it's something like the limit as x approaches infinity of 2 over x cubed minus 3x over x to the 5th plus 5. So we can't sub in infinity, that doesn't make sense, does it? But as we get bigger and bigger and bigger, we're looking at what these fractions become. Well, if you sub in 10 and then 100 and then 1,000, this fraction's going to get smaller and smaller and smaller and eventually erase down to 0, as is this one too. You can reduce that to 3 over x to the 4th, but the same thing. So that goes down to 0. And so the limit of that one just would be the 5. Okay, so you just essentially cross them out because they're 0. And this is also helpful, not just algebraically, but if you're drawing a curve and you've got the function, you don't know what it looks like, if you find out, if you sub in values of x, getting larger and larger and larger for whatever the actual function is, and smaller and smaller and smaller, often it will go to 0, or it will go to a number depending on the function, and so it helps you to draw the sketch.